So, hello everyone, good evening. So, here we shall solve some KCET previous year questions on the chapter motion in a plane. If you have any questions or doubts regarding any question or its solution, then please write us in the comment section. And if you feel that you have more difficulty in any of the chapters, then also please mention it in the comments section so that we can solve more and more questions on that chapter. And homeworks on every chapter will also be uploaded on the Sapience Education application. And so please install our Sapience Education application, whose link has been provided in the description. Okay, so we shall start here with the first question, which is being told that the maximum height attained by a projectile when thrown at an angle of theta with the horizontal. So a projectile is thrown at an angle theta with the horizontal, and it is found to be half the horizontal range. So it is told that the maximum height attained, that is equal to half the horizontal range, r by 2. Then theta is equal to how much? So we know that the range of a horizontal projectile is given as u square sine 2 theta by g, and the maximum height is given as u square sine square theta by 2g. So therefore here the maximum height is equal to half of the horizontal range. So therefore we can say that u square sine square theta by 2g, that will be equal to u square. Okay, so that will be equal to u square, once again. Okay, so u square sine 2 theta means we can say 2 sine theta cos theta divided by g, then by 2 is there, so I should write 2g. So 2 and 2 will cancel out here, and g also will cancel out, and from here u square and u square will cancel out. So from here we get sine square theta by 2, that is equal to sine theta cos theta. So therefore we can say that sine square theta minus 2 sine theta cos theta, that is equal to 0. So then if we take sine theta as common, then this will be sine theta minus 2 cos theta, that is equal to 0. So therefore sine theta will be equal to 0, or I can say sine theta, that is equal to 2 cos theta. So sine theta equal to 0 means theta equal to 0, which can't happen, which is not possible. Theta equal to 0 is not possible, since if theta is 0 means that we haven't thrown it actually. So this is the possible case which we should consider. So therefore we should tell 2 cos theta is sine theta, so therefore tan theta, sine theta by cos theta, we can tell tan theta, that is equal to 2. So therefore theta will be equal to tan inverse 2. So therefore theta equal to tan inverse 2 is the required value. So option A is the correct answer. So in any of the steps, if you are unable to understand, or any doubts if you are having in the question also or in the solution also, then please write us in the comment section. We shall clarify them in the subsequent live classes. Then here it is told that a body is projected vertically upwards. The times corresponding to height h while ascending and while descending are t1 and t2 respectively. Then the velocity of projection is, okay, so while it is going up, while ascending, the time taken to reach the maximum height, times corresponding to height h while ascending and descending. So it reaches a height h in time t1. So I can tell that, so at the maximum height, the final velocity will be 0, and suppose it is being projected vertically upwards with the initial velocity u. So I can tell that v square equals to u square plus 2gh. So g is acting downwards, so we should tell minus 2gh. So therefore v square is 0, so u square equal to 2gh. So actually from here t1 I should use it. So h is equal to actually u t1 plus half g t1 square. So g is acting downward, so I should tell minus half g t1 square. And while descending also, the final velocity will be u only, but downwards. So the total displacement is 0. So I can tell that s displacement is 0, which is equal to u into t1 plus t2 minus half g into t1 plus t2 whole square. So or we can tell that v that is equal to u minus g t1. So that is t1 equal to u by g. And finally when it will return back, then also its final velocity will be minus u, which is downward. So I can say that minus u that is equal to v is equal to u, which is 0 plus g t2. So therefore, which is in the negative sense, so I can tell minus g t2. So t2 will be equal to u by g also. So t1 and t2 both are g. Okay. So I can tell that t1 into t2 that is equal to u square by g square. So therefore u square will be equal to g square into t1 t2. So therefore u will be equal to g into root over t1 t2. So therefore here suppose so here h actually it may not be the maximum height. So let us cancel this. So here actually this is height h, so till height h, so it will go up a height h. So h will be equal to u into t1 plus so minus half g into t1 square, and then when it returns back, times correspond to height h while ascending and while descending. So this is also t2. So while returning it is t2, and while going up it is t1. So t2 that will be h will be equal to u into okay, so here the final velocity will be v equal to u, it is thrown with the initial velocity u, so it is u minus g into t1. So while returning back also the same final velocity will come, but in the opposite sense. So it will be minus of u minus gt1. So this will be h, that is equal to minus of u minus gt1 ut2 ut, this is minus h, displacement is downward, so minus h into ut t minus half g t2 square. So here h is coming ut2 u minus gt1 into t2 plus half g t2 square. So therefore we can say that ut1 minus half gt1 square, that is equal to u minus gt1 into t2, that plus half gt2 square. So if we solve it, then we'll get ut1 minus half gt1 square, that is equal to ut2 minus gt1 t2 plus half gt2 square. So therefore this will be ut1 minus ut2, that is equal to half gt1 square plus half gt2 square minus g into t1 t2. So from here we can say u into t1 minus t2, that will be equal to, so from here half g if I take as common, so then this will be t1 square plus t2 square minus 2 t1 t2. So this will be t1 minus t2 whole square. So this will be ut1 so ut1 minus t2, that is equal to half g into t1 minus t2 whole square. So therefore u will be equal to half g into t1 minus t2. U will be equal to this. So velocity of projection, okay. So actually s is equal to ut plus half at square here, okay. So s is equal to ut plus half at square and v is equal to u plus at. So u I can write it as v minus at. So if I write v minus at into t plus half at square, so then we can also say it is vt minus half at square. S is equal to vt minus half at square. So while returning back, we can say that h, that is minus h, that is equal to the final velocity is minus u, so minus u into t2, then this will be plus half gt2 square. Since it will be minus of half of minus g, a is minus g when it comes downward, so h you can say it is ut2 minus half gt2 square, and that is also equal to ut1 minus half gt1 square. So therefore we can say that this will be u in ut2 minus ut1, that is equal to half g into t2 square minus half g into t1 square. So therefore I can say u into t2 minus t1, that is equal to half g into t2 square minus t1 square. So that's why u into t2 minus t1, that is equal to half g into, so a square minus b square, we can say it is a plus b into a minus b, t2 minus t1. So these two will cancel, so then we will get u equal to half g into t2 plus t1. So option B is the correct answer. Okay, option B is the correct answer. Then the height y and the distance x along the horizontal plane of a projectile on a certain planet are given by y equal to 8t minus 5t square and x equal to 6t in meters. Both are in meters. And t is in seconds. T is in seconds. The velocity with which the projectile is projected is. So it means that we have to find the velocity of projection, that is u. Acceleration due to gravity is 9.8 meter per second square, that is g. So height y and the distance x. Okay. So height, so when a projectile is thrown at an angle theta, then the x coordinate is given as equal to, so u, the initial velocity u can be resolved into two components, which is u cos theta and this is u sin theta. So therefore the x component, so the distance traveled along the horizontal, the distance traveled along the horizontal, that is x, so that x is equal to u cos theta into t, u cos theta into t, and the height covered, that is y, means the distance covered along the vertical, that will be equal to y will be equal to u sin theta into t minus half gt square, since y g is acting downwards. So if you take the vertically upwards as the positive direction, then the vertically downwards I should choose as the negative direction. So therefore here if we compare these two, therefore u cos theta, that is equal to 6, and u sin theta, that is equal to 8, and half g, that is equal to 5, so g is equal to 10, so g we have to use 10. So therefore u will be equal to u, so we can tell u cos theta whole square plus u sin theta whole square root of that. Since y u square into cos square plus sin square theta, cos square theta plus sin square theta is 1. So that will be equal to square root of 6 square plus 8 square, that is equal to 36 plus 64, that is 100. So square root of 100 is 10. So 10 meter per second is the required velocity of projection. So option C is the correct answer. And then in the question number 4, okay, then here it has been told that a projectile is projected at 10 meter per second. So the initial velocity is 10 meter per second, and it is making an angle of 60 degree with the horizontal, and then after some time its velocity makes an angle of 30 degree to the horizontal. After some time its velocity is 30 degree to the horizontal. So tan theta, so at that time tan theta we can say that is equal to Vy by Vx, and let's say the initial angle is theta naught, then tan theta naught I can say that is equal to Uy by Ux. It means the y component of initial velocity by x component of initial velocity, and Vy by Vx means it is the y component of that final velocity divided by x component of final velocity. So g is acting vertically downwards, so the x component of velocity will remain the same. So x component will be u cos theta, u cos 60 only, and which is also equal to v sin 30. So which is also equal to v cos 30. V, since after some time the final velocity will be v, initially it is u, so v cos 30, that the horizontal component should be same, so v cos 30 that is equal to u cos 30. So u cos 30 is half, so v into cos 30 is root 3 by 2, cos 30 is root 3 by 2, So V will be equal to U by root 3. V is equal to U by root 3. So now therefore tan theta naught, so Vy will be equal to U sine 60 minus GT. So Vy, so tan 30 degree, that is equal to Vy, that is U sine 60 minus GT divided by Vx, that is equal to, so Vy is actually V sine 30, V sine 30. So which is equal to U by root 3. Simply we can solve like this also. So U into sine speed at this instant. So here the V only has been asked, V. Okay, so we use sine 60, so sine 60 is root 3 by 2 minus G minus GT, that is equal to V is U by root 3, U by root 3 into sine 30, that is 1 by 2. So therefore U, that is 10 into root 3 by 2 minus 10 into 2 root 3, that is equal to GT. So therefore G, so 2 5s are 10, so 2 5s are 10. So I can tell GT, that is equal to 5 3s are 15, 15 minus 5 by root 3, so that is 10 by root 3. So if you take G as 10, so T will be equal to 1 by root 3. So at T equal to 1 by root 3, what is the velocity V? So V, so actually only V is equal to U by root 3. So only we can tell V is equal to 10 by root 3. So 10 by root 3 meter per second. This is the answer. So option A is the correct answer. Then which of the following is not a vector quantity? Momentum is a vector, weight is a vector since it is the gravitational force of the earth, and potential energy is a scalar, and nuclear spin is a vector quantity. So the option C is the correct answer, since why energy is a scalar quantity. Any form of energy is a scalar quantity. It is not vector. So option C is the correct answer. So in any of the steps, if you are having any doubts, then please write us in the comment section. We shall clarify them in the subsequent live classes. Then a stone is thrown vertically at a speed of 30 meter per second, making an angle of 45 degree with the horizontal. 1 second. Okay, so a stone is thrown vertically at a speed of 30 meter per second at an angle of 45 degree with the horizontal. What is the maximum height reached by the stone? We have to find the maximum height, and G is given as 10. So we know that the maximum height that is given as the maximum height is given as we know that it is U square sine square theta by 2g. Okay, so u square sine square theta by 2g. So that will be equal to so u square, u is 30, so it is 30 square into sine square theta, that is sine square 45 degree divided by 2g. G is 10, so that's why it will be 900 into sine 45, that is 1 by root 2. So 1 by root 2 whole square is 1 by 2 divided by 2 into 10, that is 20. So that will be 0 0 will cancel, and 245, so 45 by 2, that is 22.5 meters. So option D is the correct answer. Okay, then it is, then the seventh question is, a particle is projected with a velocity v so that its horizontal range is twice the greatest height attained. The horizontal range is then, so the horizontal range is projected with a velocity v. Okay, so then we can say that v, that will be equal to so the horizontal range will be v square sine square theta by 2 by sorry sine 2 theta by g, v square sine 2 theta by g, and the maximum height will be v square sine square theta by 2g. So therefore now the it is told range, which is v square sine 2 theta by g, that is equal to twice of the maximum height, which is v square sine square theta by 2g. Okay, so 2g, so 2 into this. Okay, so 2 and 2 will cancel out, g and g also will cancel out, v square will also cancel out. So sine 2 theta is 2 sine theta cos theta, that is equal to sine square theta. So therefore sine theta and this sine theta will cancel out. So then tan theta, that is equal to 2. Tan theta equal to 2. So horizontal range has been asked. So sine 2 theta, let me know that it is 2 tan theta by 1 plus tan square theta. 2 tan theta by 1 plus tan square theta. Since okay, tan theta by sec theta, that is sine theta. Okay, sine theta into cos theta. Okay, so then this will be 2 into 2 by 1 plus 2 square, so that is 4 by 5. Sine 2 theta is 4 by 5. So therefore the range will be v square sine 2 theta, that is 4 by 5 into 1 by g, so that is 4v square by 5g. So option D is the correct answer. Horizontal range, so sine 2 theta we have found, tan theta is g, tan theta is 2, so 2 into tan theta by, okay, 4 by 5. Okay, yeah, option D is the correct answer. Okay. Then it is told that the ratio of the angular speed of the second hand to the hour hand of a watch is, so the second hand, so we know that the second hand of the clock, so if we have a clock, here we have the hour hand, and here we have the, suppose here we have the hour, the second, so this is the second hand, this is the hour hand. Suppose the hour hand is slightly smaller, actually the hour hand is slightly smaller, the hour hand is slightly smaller, so the speed, so we know that the second hand covers 360 degree, 360 degree, or I can say 2 pi radian in a time interval of in 60 seconds. In 60 seconds, that is in 1 minute it will cover. So then the hour hand covers 360 degree or 2 pi radian in 12 hours. So Therefore here the angular speed, or you can say omega, the angular speed is given as theta by t, means the total angle rotated divided by the total time. So therefore the angular speed of the second hand of the watch, that is equal to 2 pi radian by 60, so that is pi by 30 radian per second, pi by 30 radian per second. And the angular speed of the hour hand, that is equal to, it will rotate 2 pi radian in a time interval of 12 hours. So 12 hours means 1 hour means 3600 seconds. So this much radian per second. So 2 6 are 12. So therefore now the ratio of the angular speed of the second hand to the ratio of the hour hand, so that will be pi by 30 is to pi by 6 into 3600. So that will be equal to pi by 30 into 6 into 3600 divided by pi. So that will be so 0 0 will cancel, pi will cancel, 3 2s are 6. So 720 is to 1. 720 is to 1, which is option C. So option C is the correct answer. Then it is told that the three projectiles A, B and C are projected. A, B and C are projected at an angle of 30 degree, and B is projected at an angle of 45 degree, and C is projected at an angle of 60 degree. If RA, RB and RC are the ranges of A, B and C respectively, it means that the range of A is RA, the range of B is RB, the range of C is RC. Then velocity of projection is same for A, B and C. The velocity of projection is same for A, B and C. So the range of A, that will be equal ranges of A, B and C. Then we have to find what is the relation in between RA, RB and RC. Are they equal or they are not equal? So RA will be U square sine 2 into 30 degree by G. RB will be U square sine 2 into 45 degree by G. Okay. And then RC will be U square. And since we have taken U as the initial velocity for all of them, since here it is told that the velocity of projection is same for all of them, means the projectile A is also being projected by the initial velocity U, B is also being projected by the initial velocity U, and C is also projected by the same initial velocity U. So U square sine 2 into, it is 60 degree divided by G. So this will be U square sine 60 degree divided by G, and this will be U square sine 90 degree divided by G, and this will be U square sine 120 degree divided by G. Okay, so then therefore RA, that is equal to root 3 U square by 2G, and RB is U square by G, and RC is also 120, sine 120 means 180 minus 60, that is same as U square sine 60 by G. So that is also same as root 3 U square by G, 2G. So therefore you can say that RA, that is equal to RC, but root 3 by 2, that is obviously less than 1. Root 3 by 2, the value is obviously less than 1, since root 3 is less than 2. So therefore root 3 by 2, that is obviously, this is less than RB, that is RB. So RA equal to RC, which is less than RB. So option D is the correct answer. In any of the questions, if you are having any doubts in the solution or in the question, then please write us in the comment section. Then question number 10 is the component of a vector r along x-axis will have the maximum value if component of the vector r, if r is along positive x-axis and r is along positive y-axis, okay. Yeah, the component of, so r cos theta, suppose r vector is like this, and this is x-axis and this is y-axis, so this theta, so therefore the component of r vector along x, that is rx, that will be equal to r cos theta. So r cos theta will be maximum when theta is equal to 0 degree. So it means that r cos theta is maximum, when theta is 0 degree. It means that the component of r vector along the x-axis, which is rx, will be maximum when r vector is along the positive x-axis, so therefore option A is the correct answer. Then it is given that a vector is 2i cap plus 3j cap plus 8k cap, and it is given that a vector is perpendicular to b vector. Then the value of alpha is, so b vector is given as 4j cap minus 4i cap plus alpha k cap, and the value of alpha is how much? Alpha we have to find. The value of alpha we need to find. So then a dot b that is equal to 0. A dot b that is equal to 0. So a dot b should be equal to 0. So therefore 2i cap plus 3j cap plus 8k cap dot product with 4j cap minus 4i cap, 4i cap plus alpha k cap, that should be equal to 0. So therefore I can say that 2 into minus 4, that is minus 8, plus 3 into 4, that is 12, plus 8 alpha, that should be equal to 0. So therefore 8 alpha should be equal to 8 minus 12. So 8 alpha, that should be equal to minus 4. So alpha should be equal to minus 1 by 2. So option D is the correct answer. Then it is told the angle between velocity and acceleration of a particle describing uniform circular motion is, angle between velocity and acceleration, okay, so when it is performing uniform circular motion, then velocity is along the tangent and acceleration is on the only acceleration is along the center, which is the centripetal acceleration. So acceleration, so here the acceleration vector is along the radius, which is radially inwards, direction, and the velocity v vector is along the tangent. So therefore the angle in between velocity and acceleration, is 90 degree. So therefore v vector dot a vector, that should be equal to 0. So the angle in between velocity and acceleration should be 90 degrees. So option C is the correct answer. Okay, then it is told that the trajectory of a projectile projected from the origin is given by the equation y equal to x minus 2x square by 5. And the initial velocity of the projectile is how much? Initial velocity of the projectile, okay. Trajectory, okay. So first we need to find the equation of trajectory of a horizontal projectile. We know that if projectile is projected with a velocity u at an angle of theta with the horizontal, then the distance traveled along the x-axis means the distance traveled along the horizontal, that is x, that is given as u cos theta into t, and the the distance covered along the vertical, which is y, that is equal to u sine theta into t minus half gt square. So therefore t will be equal to x by u cos theta. Now therefore y will be equal to u sine theta into t, which is x by u cos theta minus half g into t square, which is x by u cos theta whole square. So therefore u will be equal to, so u and u will cancel, then we will get x tan theta minus half g x square by u square cos square theta. So it means that if I tell that, so this is the required equation of the trajectory. So this is the required equation of the trajectory. So x equal to, I can tell tan theta into x, and minus this is g by 2 u square cos square theta. Sorry, yeah, g by 2 u square cos square theta into x square. Okay, so therefore so if we compare these two equations, we can say that therefore the coefficient of x in the equation of the trajectory will give us the tan theta, and the coefficient of x square will give us the value of minus g by 2 u square cos square theta. This value can be obtained. So now therefore if we compare these two, then from here we can see that the value of tan theta, that is equal to 1, and g by 2 u square cos square theta, that is equal to 5. Sorry, that is equal to 2 by 5. So therefore we can find, so therefore tan theta we have got, that is equal to 1, and g by 2 u square cos square theta, that is equal to 2 by 5 here. Okay, 2 by 5. So then from here we can say that theta equal to tan, so tan theta is tan 45 is equal to 1, so I can say theta is 45 degree, and then g that is equal to g that is equal to g that is equal to 10. Suppose if you take g as 10, g let us take it as 10 meter per second square. So therefore 10 by 2 u square into cos square 45 degree, that is equal to 2 by 5. So therefore we can say u square, so 2 u square into cos square 45 is 1 by 2, since cos 45 is 1 by root 2. So that divided by 10, that is equal to 5 by 2. So 2 and 2 will cancel. So u square will be equal to 10 into 5 by 2. So 2 5s are 10. So u square is equal to 25. So u is equal to 5. So therefore the initial velocity of the projectile is 5 meter per second. So option D is the correct answer. U is 5 meter per second. Then so any doubts if you have in any of the solution steps or in understanding the question also, then please write us in the comment section. We shall clarify them in the subsequent live classes. Then it is told that rain is falling vertically with a speed of 12 meter per second. Rain is falling vertically downwards. Rain is falling vertically downwards with a speed, we can tell velocity of rainfall, that is 12 meter per second, and a woman rides a bicycle with a speed of 12 meter per second in east to west direction. East to west. So we can say that this is east, this is west, this is north, this is south. Okay, so but this is actually, this we can say it is upwards, it is downwards, and north and south, that is like this we should say. It is a three-dimensional figure actually. So the woman is riding the bicycle with a speed VW, we can say, that is equal to 12 meter per second. What is the direction in which she should hold her umbrella? So it means that the velocity of the rain, we can say it is 12 meter per second j cap, and this is velocity of the woman, we can say it is 12 meter per second I cap. So it means that the direction towards the left, we are taking it as the positive x-axis, and the vertically downwards, we are taking it as the positive y-axis. So now we have to find the velocity of the rainfall with respect to the woman. That will be equal to velocity of rainfall with respect to ground. It is actually, this is also velocity of the woman with respect to the ground. So we have to find velocity of rainfall with respect to the ground minus velocity of the woman with respect to the ground. So that will be equal to 12 meter per second j cap minus this is 12 meter per second I cap. So that will be equal to 12 into j cap minus I cap meter per second. So it means that j cap minus I cap, so the component of the velocity of rainfall with respect to the woman, that is, it has 12 meter per second along the y component and 12 meter per second along the negative x component. Okay, so the velocity of, so the rain is falling like this. So it is, so I can say that the angle theta it makes with the horizontal or with the vertical, that is same, which is 12 by 12, which is 40. So tan theta is equal to 12 by 12, which is 1. So theta is 45 degree. So the woman should hold her umbrella like this, so which should oppose the rainfall. So she should hold her umbrella at an angle of 45 degree towards the west. So she should hold her umbrella at an angle of 45 degree with the vertical towards the west. So 14, she should hold her umbrella angle of 45 degree with the vertical. So she should hold her umbrella 45 degree with the vertical towards the west. So it means that option B is the correct answer. Then we shall solve the last question in our live class. So here it is given that a wheel starting from rest gains an angular velocity of 10 radian per second after uniformly accelerated for 5 seconds. So here the acceleration is called as angular acceleration. It's called as angular acceleration, which is represented by alpha. So alpha is uniform here. Alpha is uniform. So angular acceleration is uniform. So I can use the equation which is v square equal to u square plus 2as, which is so in the linear velocity and in case of linear acceleration, we should write v square equal to u square plus 2s. But in case of the in rotation, when the angular acceleration is constant or uniform, then we can write it as omega final square, that is equal to omega initial square plus 2 alpha theta, where omega final is the final angular velocity, and omega initial is the initial angular velocity, and alpha is the constant angular acceleration, and theta is the amount of angle rotated, So therefore now 2 alpha theta, that we can say it is omega final square minus omega initial square. So therefore theta, how much angle it has rotated, the total angle through which it turned, we have to find how much angle through which it turned, that is how much. So theta, that will be equal to omega final square minus omega initial square by 2 alpha. Therefore the angle alpha so the angle alpha, the angle theta through which the wheel has rotated, it starts from rest. It has told that it starts from rest, so initial angular velocity is 0, and omega final is 10 radian per second. So theta will be equal to omega final square, that is 10 square minus 0 square by 2 alpha. Okay, uniformly accelerated by for 5 seconds, so that alpha we have to find. So alpha, so here actually we can also use the formula, that is s equal to ut plus half at square, since here time has been given. So this is in the linear form. In case of constant linear acceleration we should use this, but in case of constant angular acceleration, it means for rotation we should use that theta equal to omega initial into t plus half into alpha t square. So therefore here omega initial is 0, and so here we can also use v equal to u plus at. So its rotational analog, we have to write the rotational analog of this equation, u plus at. So omega final, that is equal to omega initial plus alpha t. So here alpha will be omega final minus omega initial by t. So alpha will be equal to omega final, that is omega final, that is 10 minus omega initial 0 by t, which is 5. Here it is told t is 5. Uniformly accelerated for 5 seconds. So therefore alpha is 2 radian per second square. So now therefore theta will be equal to 100, 10 square, that is 100 by 2 into alpha, that is 2 into 2. So 4 into 25 radian. So 25 radian is the answer. So option C is the correct answer. So thank you everyone. The live class is over, and any doubts if you are having, please write us in the comments. We shall obviously clarify them. And any other chapter, if you feel it is very difficult for you to solve the questions, then please write the name of that particular chapter in the comments section, and then we shall solve some more and more questions on that chapter, and so it will be helpful for you. Thank you.